In this video, I will walk you through free response question number 1 from the 2011 AP Calculus exam. This problem is about position, velocity, acceleration, and the first fundamental theorem of calculus. For the interval from 0 to 6, a particle is moving along the x-axis. The particle's position, x of t, is not explicitly given. The velocity of the particle is given by v of t equals 2 sine of e to the 2 divided by 4 power, plus 1. The acceleration of the particle is given by a of t equals this, and x at 0 equals 2. This problem is calculator active, so we will be using our graphing calculator as needed. Part A. Is the speed of the particle increasing or decreasing at time t equals 5.5? Give a reason for your answer. Here are some notes that you will need in order to answer this question. Speed is increasing if the velocity and the acceleration have the same sign. Speed is decreasing if velocity and acceleration have different signs. So our strategy will be to find the velocity and the acceleration at t equals 5.5 and find out if they have the same sign or different signs. Let's type the velocity and acceleration equations into our calculator. Hit the y equals button. I always type the position function onto y1. I put the velocity equation on y2, and I put the acceleration equation on y3. That just helps me keep track of which one is which for later. We are given this velocity equation, so I will type this in as y2. And here it is. I have to use x instead of t, but that's fine. They gave us this equation for acceleration, so I will type this in as y3. So here is my acceleration function. I need to evaluate both of these at t equals 5.5. Before I do that, I would like to use the table feature, but you have to set it up in a special way. Hit second window to get to the table setup menu, and make sure your independent variable is set to ask, and you can leave the dependent variable set to auto. Once you have done that, then hit second table. Remember that we stored the velocity function under y2 and the acceleration function is stored under y3. I can evaluate both of these simultaneously at t equals 5.5 by typing in 5.5 and hitting enter. Kabam! It's just that easy. As we saw on the calculator, the velocity at t equals 5.5 equals negative 0.453. The acceleration at t equals 5.5 is negative 1.359. The speed of the particle is increasing at t equals 5.5 because the velocity and the acceleration are both negative at t equals 5.5. Part B. Find the average velocity of the particle for the time period from 0 to 6. There are two ways to calculate average velocity. There's a method that we learned first semester, and then there's a method that we learn in second semester. We know that velocity is the change in position divided by the change in time. We were told in the setup that x of t is the position function for this problem. So the change in position will be x at b minus x at a, divided by the change in time, which would just be b minus a. So this is one way to calculate average velocity. You basically do an old school slope. Think y minus y over x minus x. Here's how we could write the same thing using integrals. Think about it. The integral of velocity is position. So we would end up with x of t, but this is a definite integral. And the way you evaluate from a to b is you take the value at b minus the value at a. So this would end up being x at b minus x at a. So what you see in the numerator is really this, which is really the same as that. If we want to calculate the average velocity for the time period from 0 to 6, that means that the a value is 0 and the b value is 6. So we have this and we have this. Which method are we going to use for this problem? Well, in the setup, they gave us a formula for velocity and for acceleration. They did not give us a formula for position. So we can't really use this one. So we're going to do this. In the denominator, 6 minus 0 is just 6. And we will often rewrite this as 1/6 times the integral from 0 to 6 of velocity. This just makes it a little bit easier to type into the calculator. So let's type this in. So first we have that 1/6, which we can just write 1 divided by 6. Now we need the integral from 0 to 6. Hit the math button. Option number 9 is for integrals. And we type in the limits of integration from 0 to 6. We want to integrate the velocity function. Remember that we put the velocity function under y2. We can access that by using the vars button, switch over to the yvars menu, choose option number 1 for function, and then you see y2. Pick that. So here we are integrating y2, which is the velocity function. Go ahead and put an x right here, and that's it. So the answer is 1.949. So you could record your final answer just like this. Here's something that I always think in my head to help me remember this formula for average velocity or average acceleration, average position, etc. The average value of whatever it is equals integral over interval. See what I mean? It's the integral divided by the interval. Part C. Find the total distance traveled by the particle from time t equals 0 to t equals 6. Here is one version of the first fundamental theorem of calculus. Since velocity is the derivative of position, the first fundamental theorem of calculus tells us that the integral of velocity from a to b is the change in position from a to b. There is one sneaky word in this problem that I don't want you to get fooled by, and it is the word total. The formula that we get from the first fundamental theorem of calculus is for the net distance. The net distance traveled by the particle will be the integral of the velocity from 0 to 6. But the net distance is not the same as the total distance. For the total distance traveled by the particle from 0 to 6, you need to integrate the absolute value of the velocity from 0 to 6. Here's how you type it into your calculator. We are still doing the integral from 0 to 6. So hit the math button, choose option 9 for integration, type in your limits of integration from 0 to 6. Now, pause for a second. We want the absolute value of the velocity function. So for absolute value, hit the math button again, switch over to the num menu, and this ABS, option number 1, is absolute value. So kabam. And we want the absolute value of the velocity function, which we stored under y2. So hit the vars button, switch to the yvars, choose option 1, and select y2. So here we go. The integral of the absolute value of the velocity function from 0 to 6 is, don't forget the x, kabam! 12.573. That's really all there is to it. Notice that you do not get the same answer if you type it in without the absolute value. the total distance will always be longer or equal to the net distance. Say you were traveling from time A to time B, and you took this crazy route that I'm drawing right now. The net distance is just the distance from A to B from the shortest path possible, whereas the total distance is the actual length of the entire crazy path. So the net distance will always be less than or equal to the total distance. Part D. For the time interval from 0 to 6, the particle changes direction exactly once. Find the position of the particle at that time. Here are some notes that you need to understand this problem. Direction is indicated by the sign of the velocity. If v at c is positive, the particle is moving to the right at t equals c. If v at c is negative, the particle is moving to the left at t equals c. Therefore, if the particle changes direction at t equals c, that means the velocity changes signs at t equals c. We have the formula for the velocity of this particle. Let's graph v of t and see where it changes signs. Click on the y equals button. Here are the two functions that we have typed in. y2 is the velocity. That's the one we want to graph. So let's turn the other graph off by highlighting the equal sign and hitting enter. And let's see. Let's hit zoom 6 and see what happens. Zoom 6 gives you a 10 by 10 window. Actually, we are only interested in values of t between 0 and 6. So let's adjust the window on the calculator. Hit the window button and let's let the x max be 6 and the x min be 0. That will give us values from 0 to 6. Hit graph again. We can see that the velocity function only changes signs at one spot, as we were told that it would. And it happens right around here. We can estimate this is 1, 2, 3, 4, 5 point something. Yeah, I'm going to say 5.15, maybe, something like that. Let's find what this value of t actually is. Let's hit second trace and choose the 0 function, option 2. The calculator is asking for left bound, so just make sure you are to the left of the x-intercept. Okay, anywhere over here is fine. Hit enter. Now the calculator asks for a right bound. Slide over to the right of the x-intercept and hit enter. Now the calculator asks for a guess. Slide over right about where the x-intercept appears to be and hit enter. And here it is, 5.196. Or you could put 5.195 and that would be okay for the AP exam. Notice one more time, the velocity is changing from positive to negative at t equals 5.196. Before we go on, I need to show you how to store this value into memory because we will need this later, and unless you want to type in all of these decimals by hand, you should store it as a variable on your calculator. Let's quit our way out of this by hitting second quit, and go ahead and type the x value and then the store button. So we are going to take the x value that we just found and store it into whatever variable we choose. I'm going to use letter A, so I will do alpha A and enter. So now this entire decimal is stored in variable A. Here's what we have so far. The velocity at time 5.196 equals 0, and the particle changes direction at t equals 5.196. I've checked the answer key, and they really want you to mention that the velocity is equal to 0 at time 5.196. So make sure to include that in your answer. Be careful though, we are not being asked to find at what time the particle changes direction. We are being asked to find the position of the particle at that time. Here is the version of the first fundamental theorem of calculus that gives us the relationship between position and velocity. The end position will equal the initial position plus the integral of velocity from A to B. In the setup of the problem, we were given this little nugget right at the end. X at 0 is equal to 2. That's the initial position. So we can substitute that right in here in the first fundamental theorem of calculus. If I want to find the position of the particle at time t equals 5.196, I can do this. X at 5.196, right, that'll be the end position, will equal the initial position, which is 2, plus the integral from the initial time 0 to the time 5.196 of v of t dt. We can type all of this into the calculator to get the final answer, but be careful. When we do it, we don't want to type in 5.196. That is a rounded value. Instead, remember that we stored the whole decimal into the letter A. So that's what we will use. So getting back to the calculator, we want to do 2 plus the integral. So hit the math button and choose option 9 for integral. And we are doing 0 to 5.196, but we will use letter A instead. So alpha A. And we are integrating the velocity function, which again is stored under y2. So hit vars, y-vars, function, y2. And put the x in, and kabam. The answer is 14.135, or 14.134. In summary, we add that the position of the particle at t equals 5.196 is 14.135, but all of this needs to be included in your answer.